Alright, we're going to solve this logarithmic equation. I see an equal sign, so it is an equation. I have some logs in here. And when I get down to my answer is going to be x equals something. Okay, it's going to be a number if there is an answer. I say that because remember, we have a domain restriction with logarithms. Your logarithm is only on the positive side of 0, on the right side of 0. If you go back here to -1 or -2 or -3, you have no graph back here. So when you take the logarithm of something, it has to be greater than 0. Okay, so if you end up getting a log of a negative, that's not going to exist. Okay, keep that in mind. I'll leave that up here. All right, let's go solve this problem. I have two logarithms with the same base. That's really nice. And first thing I can notice with the two different logarithms, I'm going to condense these into one logarithm. So let me go and look at my properties here. And I'm going to use this one right here, the logarithm product rule. I notice that if my two logs have the same base and they're added, I can put them together as one logarithm, and they're going to be multiplied inside of that logarithm. Okay, so let's go and apply that. Two logarithms are going to turn into one logarithm, the log base 6, and these two things are now going to be multiplied. So it's the log base 6 of x plus 8 times x plus 3, and it still equals 1. Now, my x's are both in here, stuck inside the logarithm. So I can get them out. I go back to my properties here, and if I use this definition of a logarithm here, you notice that the x, which was stuck inside of the logarithm, can come out and be by itself. And the way that we do that is we take the base, this base of b, we make it a big base of b, and then the other two things are going to switch sides. Okay, the y comes to the right and the x goes to the left. Okay, so let's apply that. My base of 6 becomes a big 6. This 1 that was on the right is going to move to the left, and it becomes my exponent of 1. And then these two binomials, this thing inside the logarithm is going to go to the right. And it's going to be out of the logarithm now. X plus 8 times x plus 3. All right. So I've gotten my x's out of the logarithm. Now I need to solve. Okay, and this is a quadratic equation at this point. If you took everything else away, you'd say, oh, look at that, that's a quadratic equation. So in order to solve a quadratic equation, we are going to need to get it equal to 0. Okay, we're going to need to move that 6, and we're going to need to incorporate it into these two binomials. The way we're going to do that is we're going to have to FOIL the right-hand side. Let's go ahead and multiply them out, FOIL them out. We'll get x squared, first two, outer two, inner two, last two. And now it's going to be a lot easier to see that when you subtract 6 from both sides, so we'll have a 0 on the left, that the 6 is going to incorporate itself into this polynomial. 6 minus 6 is 0. 0 equals x squared. Now let's go ahead and put these together. Plus 11x. And then plus 24 minus 6 is 18. And now this is the polynomial you are probably used to seeing. All right, this quadratic equation. Once we have it equal to 0, we can factor the right-hand side. X and x, 2 and 9, plus and plus. And then we could set both of our factors equal to 0. Okay, all of our factors equal to 0. If this was 0, the whole thing's 0. If this was 0, the whole thing's 0. So x plus 2 equals 0, and x plus 9 equals 0. solve those two linear equations to find x equals -2 and x equals -9. Okay, so I'm so excited that I just got two numbers for this problem that I go and I put them in to my computer program and I click submit. It tells me that I'm not correct. All right, the reason I'm not correct is because of this right here. Okay, domain restriction. Remember that you can't take the log of a negative number. Now the -2 is fine. It works out perfectly fine if you plugged in a -2 into the original problem. But let me show you what happens when you plug in this -9. Okay, let me rewrite it. Let's see if I can do some computer magic and just copy this and paste it over here. There we go. That's good enough. Now, if I took that -9 and I plugged it in here and here, let's see what's going to happen. Okay, so this is going to be, whoops, that's too big. Let's try it like this. Let's plug in a -9 here and a -9 here. Well, now I have the log base 6 of -1. Can't have that. Okay, I can stop right now. I'm going to also get an error when I try it here. Log base 6 of -6. Okay, you can't have a negative inside of a log, and so I have to take this answer and throw it out. So the answer is, the only answer is x equals -2. Okay, and if you took this -2 and you plugged it in right here, you'd be okay, right? Let me show you that real quick. Let's put this -2 right here. -2 plus 8, -2 plus 3. So -2 plus 8 is 6. There's nothing wrong with a 6. The log of 6, I can have that. And then the log of a +1, that's also fine. I can have the log of a 1. Okay, so there's nothing wrong with the -2. But I need to leave it like this to show you that the -9 does not work out. So that's my only answer.